Okay, well, thank you very much for the opportunity to speak. That was a very exciting talk, and I hope this will piggyback off of the last one nicely. As sort of a silver lining to us all meeting over Zoom, the room that we had booked at the M&I could just barely squeeze in 40 people, and I saw that we were 65 earlier today, so this is actually a really great turnout. I'm going to talk to you about Appian, which is sort of a side project I developed during my PhD and has become a bit of a labor of love. So it is an open source package for automated pet analysis. You can find it on GitHub. And it's written mainly using NiPipe and NiBabel. So it's mostly in a Python environment. And sort of the overarching aim was to automate all the processing steps between or after reconstruction, all the way through, but not including the statistics that you might run on your data at the end. And Appian is meant to be used primarily through Singularity and Docker, so it comes containerized. So why did we bother to create Appian? I mean, now there's a lot of open source tools. There weren't that many when we initially started. But like I said, the idea was to have a complete processing package. Also, it should be, the way it's written is intended to be easily extendable. So for example, it doesn't include motion correction at the moment, but that's something that could easily be added if somebody wanted to take the time to do that. It's also meant to be very flexible, so it allows for many different types of experimental designs. And also because it's written using NiPipe, you can write a NiPipe wrapper for any sort of software. So if you have old Fortran code kicking around from the 80s, you could write a NiPipe wrapper for it and run it within Appian. Because it's containerized, it makes it easier to do reproducible analysis because you can use exactly the same version of Appian 5 years from now or something like that if you're trying to reproduce results in the future. And we also wanted to try and make the analysis that's done by Appian robust by including visual and eventually automated QC. Just to give you a brief overview of the main steps within Appian, the first step is to do pet MR co-registration. The next is to optionally do partial volume correction, and then quantification through some kind of model fitting, and then an automatic extraction of results that can then be used for statistical analysis. One of the more sort of interesting and kind of complicated parts about Appian that makes it very flexible is that you can just find labels for each of these steps in a manner of different ways. So the labels that you would use for partial volume correction constrain the partial volume correction algorithm to certain anatomic regions. For quantification, it provides a reference region. And then for the results, it defines the ROIs that you actually want to extract results for. Also, a future extension could be to use anatomic labels for the co-registration step so that you can constrain the co-registration to anatomic regions with high radioligand uptake, for example. So this is more of a thorough outline of Appian, but I won't go through it. I just wanted to show you that it's a little bit more complicated than what I just showed. So one of the first steps is actually MRI pre-processing. The first thing is to align the subject's MRI to the MNI 152 atlas, or optionally another template. This can be done using, it's done using ANTs, but the user can specify if they want to do it with rigid alignment, affine, or nonlinear. And the user can tweak what sort of parameters they want to use, because it's very important. For some subjects, it might be enough to do a simple nonlinear alignment, but then if you have a cohort of Alzheimer's patients with really sort of distorted ventricles, you might need to play around with that. Next step is to do intensity normalization for the MRI to correct for inhomogeneity in the MRI scanner. And then brain mask extraction. This was formerly done using BIDS, but because I converted the whole thing from Mink to Nifty and BIDS is a Mink tool, I'm actually looking for a good brain mask extraction algorithm if somebody knows one with a permissive license. And then after that, we do a simple tissue segmentation with ANTS Atropos. It's a bit crude, but it provides you at least with a few regions of interest that can be used for like automated analysis. Then for defining the regions of interest, there's three sort of main paradigms you can use. One is simply to define or to use an MNI 152 atlas. So because Appian will automatically align the patient's MRI or the subject's MRI with the MNI 152 template, you can use whatever atlas, like the DKA atlas, and define regions within that, and it automatically gets mapped to your subjects. You can also use a non-MNI 152 atlas and template, and you provide that in the command line, and then Appian will automatically align that to your subject. You can also have subject-specific ROIs. So for example, we did this for a stroke study where we had manually segmented stroke infarcts, and so we had a separate one for each subject. So all of these three possibilities are supported within Appian. There's also options for modifying your atlas or the labels that you use. So you can select specific ROIs from an atlas. You can concatenate them together into a single ROI. You can intersect them with the brain mask. And then you can also erode the ROI, which is useful if you're defining a region of interest for kinetic modeling. And this is also something that's very flexible. So if somebody has an idea, maybe it's useful to, I don't know, dilate an ROI or something else, let me know, and that could definitely be implemented. Oops. So next is partial volume correction. At the moment, so there's both ROI based and voxel-wise based correction. At the moment, only PET PVC is included because it's the only package that I know of in Python that's available. But if somebody knows another one, then that could definitely be incorporated as well. Quantification. So before I was using the Turku tools, but those were a little bit hard to interface with. So I switched to just starting writing my own algorithms for this. But after having seen the last presentation, like this is not even worth going into too much. So yeah, this is something that is done in Appian, but oops. I think, did
Yeah, you just unshared it, exactly. I think you need to reshare. The computers are all running hot in the seat and getting into problems with the screen sharing. They're excited, like, ooh.
Yeah. Okay. Is this on the presentation mode one, or?
I think this is still the yeah, exactly. Let's. It's coming.
Okay, there we go. Right, so in the future, maybe we could look to incorporating Kinfitter into this in some way. So that'd be very exciting. Okay, finally, next is the extraction of quantitative results from each of the ROIs that are defined using your specific labels. And what's kind of cool about BIDS is that it makes it easy to sort of automate the statistics that you would do because it defines very specific labels that you use to describe your data. So like subject, session, task, run. And so I give a little example here of how you could just easily run a simple mixed effects model in one line by sort of reading in the data, and then you have your model here, and then you could very easily do statistical analysis without having to muck around with your data after having run Appian. And then there's a quality control portion. There's an automated QC algorithm that I developed, which is still sort of in progress. I'm still validating it, so I won't go too much into it. The basic idea behind it is that you calculate a QC metric for each scan at each processing stage. And then you identify outliers in the distribution of QC metrics for each processing stage. There's also a visual QC portion, which consists in a very lightweight HTML dashboard where it loads GIFs of the major processing stages so you can have a look at your data and see what it looks like. And the idea behind this is that instead of having a very complicated sort of JavaScript heavy dashboard that's hard to maintain, the idea is that you'd run your Appian on a HPC cluster. And then you would download just the GIFs, which is much more lightweight, look at it on your computer, and if it looks okay, then you can download all the data. If it doesn't look okay, then maybe you need to tweak something in the parameters. So I'll quickly show you a couple of examples. For this, I'm using the NRM 2018 Grand Challenge dataset and one subject in particular. So the minimal options that you would use to run Appian are just here. You just specify what is your BIDS directory, your output directory, optionally what subjects you want to run, and then the dashboard option will create the dashboard. And so this will automatically align the MNI 152 atlas to the MRIs, segment the MRIs, align the PET to the MRI, and extract time activity curves for the ROIs, which are defined by the segmentation. And from the dashboard, you'd get something that looks like this, where you can see there's 2 QC images for the co-registration, one with the PET image superimposed with the edges of the MRI, and then one just with the PET and the MRI together. If you want to do something a little bit more complicated, then we can use MRI intensity normalization, use the DKA atlas for a cerebellar reference region. So you define the path here, the labels you want to use, and then you concatenate the labels together. Calculate, say you want to use the Logan plot, the start time, and then we can erode the reference region by 3 voxels to avoid partial volume effects, for example. And then you'd get time activity curves and a visual image of the BPND image. And then as a third example, we can then define ROIs for the results from, for example, the Colin 27 atlas, where we have a separate template and a separate atlas, and then use partial volume correction with the GTM using full width half maximum for the scanner that's specified here. And then you'd get something like this from the dashboard. And so there's a lot of things to do in the continuing development of Appian. One is obviously improving the visual QC and also validating the automated QC. I was going to say including more PET models, but we had a great talk about that just before. And also, so far, this is very user-friendly. If your idea of user-friendly is running things by the command line on an HPC cluster. But for a lot of people, that's it's a big ask. So I'm still working on getting it uploaded onto an online platform called CBrain, where you'd be able to use a sort of a semi-GUI to specify all the run options you want to use. And so just a little bit about us, because it's not just me. There's Kevin Larcher, who now works at Biospective, PJ Toussaint, who I believe is in the meeting, and Lisa Levitis, who has now started a PhD at the NIH. So that's it. If there's any questions?